So now that we talked about periods and all of that stuff, we're going to be looking at the sine graph now. So the sine graph is a special graph that follows the sine ratio. So if you look at what we did in trigonometry with SOHCAHTOA, you obviously know sine is opposite over adjacent, but in this case, given a specific angle, the value differs. So the key values we're going to focus on, because you're not going to be writing them all down, all you're literally doing is plugging this into your calculator. We'll focus on 0, 90, 180, 270, 360, and 540. And 450 as well. So all you're literally doing here is just punching in sine on your calculator, then the angle, so in this case 0, and pressing equal. So when I have sine of 0, I get a value of 0. Now let's do the same thing. Sine of 90, so sine 90 on your calculator, press equals, gives me 1. Sine 180 gives me 0. Sine 270 gives me -1. Sine of 360 gives me 0. Sine of 450 gives me 1. And sine of 540 gives me 0. So these are going to be more than sufficient enough for you to graph the sine function. So if we go down to our next page, we are going to graph the sine function. So again, we're starting at 0, 90 degrees, 180, 270, 360, 450, and 540. So we have 1 is our maximum and -1 is our minimum. So now let's plot the points. So sine of 0, we got 0. Okay, sine of 90, we got 1. Sine of 180, we got 0. Sine at 270, we got -1, back to 0, back to 1, back to 0. So if we were to draw this curve, which I should be drawing a bit better, so this is what our sine function will look like. And sine function is continuous, so it will continuously go and go. So again, when we're talking about the period, we're talking about top to top. So if you go from top to top, from 90 to 450, that is going to be 60 degrees, 360 degrees. So the period of my sine function is always going to be 360 degrees. Now my equation of the axis, remember, I'm going to take my highest point, which is 1, add it to the lowest point, which is -1, and divide by 2, which gives me 0 over 0. So the equation of my axis is y is equal to 0. Now my amplitude is how far from the axis of symmetry is my highest and lowest point. So remember, for the amplitude, which is over here, I need to do the highest point minus the lowest point divided by 2. So 1 minus -1 is 2 divided by 2, which is 1. So my amplitude is going to be 1. And now for my intercepts, those are where my graph crosses the x-axis. So I'm going to label these a different color. So let's put it yellow. So at 0, 180, 360, and 540, those are when my graphs hits the x-axis, which is considered my intercepts. So at 0, 180, 360, and 540. So for my domain, for the sine function, the domain of any sinusoidal function is XER. Okay? Now my maximum is 1, my minimum is -1. So again, like in unit 1, we're going to start a range with YER. But my restriction is, remember when we have a max and a min, we have to put the y in the middle, the highest point on the right and the lowest point on the left. And we are going to put our inequalities in that specific way. So my range is YER such that y has to be bigger than -1, but less than +1. So we're identifying the 5 key points. So over here, we know we already did that already. So it's going to be 0, 0, 90, and 1. We have 180 and 0. We have 270 and -1. And we have 360 and 0. So those are going to be my most important points when it comes to graphing the sine function. So if you notice the sine function, it starts at the equation of the axis in the middle and goes up. Okay, that's how it will always start. It'll start at the equation of the axis and move up and then go down after that. So in this last example, we have sketched 2 cycles of a periodic graph, which has 2 of the following characteristics. We have a max of 0.6, an amplitude of 0.8, and a period of 200, and it starts at 0, 0. So this is our starting point, 0, 0. So we know it has a max of 0.6 and an amplitude of 0.8, and the period is going to be 200. Which means that it's going to stop over here and all the way down here. So again, like any sine function, remember we have our x-intercepts. We have 1, 2, 3, 4 of those. So because we're drawing 2 cycles here, we're going to have to figure out how we might be able to do this. So our amplitude is 0.6, which means the max is 0.6. So our max is going to be at 50, which is 0.6 over here. And it's going to hit 0 at 100. But because our amplitude is different, we need to work with it. So it starts at 0, 0. Our first max is at 0.6, which is at 50. Because the amplitude is 0.8, to find my axis of symmetry, I need to take 0.6 and subtract it from my amplitude of 0.8, which gives me 0.2, negative 0.2. So the next one would be, to find my minimum, it would be negative 0.2 minus 0.8, which means I get 1. So at 150, I'm going to be at 1. Then it's going to continue over here. At 250, it's going to be 0.6. At 300, it's going to be negative 0.2. And at 350, it's going to be 1. And then it's going to head back up to here at 400. So now, because we start at 0, let's draw this graph out. So this is how this graph would look like based off our description. Okay, so the key points to plotting a sine and to plotting a sine graph is the 5 key points. So if we make our table of values, We have x, y, 0, 90, 180, 270, 360. So you have 0, 1, 0, -1, and 0. Okay, so those are just the key information you need to plot the sine graphs. And then there are transformations of sine graphs, which we will get to in the next lesson, so just keep an eye out for that.